All right, hit Stat, Edit. And we'll enter the data that we were given. Okay, our X and Y table. Our X values are -2, -4, and 0. The Y values that we have are 4, 3, and 3. Okay. What's my next step? Stat Calc. Okay, so what we'll do is we'll hit Stat, and then we'll go over to Calc. Raise your hand if you think we're going to hit 4. Okay, this is not, because we're doing quadratics, we're not going to be doing, so it's time for you to finally learn what this means. Has anybody ever told you what LINREG stands for? Linear regression. Very good. So if that's linear regression, and I've got a quadratic function, what should I use? Quadratic regression. Quadreg. So go down to 5 and hit enter. Make sure that, this should default to L1 and L2, and just hit enter, 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 enter. And what it actually gives you the standard form equation of a quadratic function. ax squared plus bx plus c. Please write that, write it small on your whiteboards, but change that y and put f of x equals ax squared plus bx plus c. Then below that equation that you wrote, you just wrote f of x equals ax squared plus bx plus c. Below that, I want you to write f of x equals, again, but then replace the a, replace the b, and replace the c with the values that you computed using Stat Calc Quadreg. In other words, I want you to write an equation for this quadratic function. Show me your board when you've got the equation written. What's the middle term? Okay. Okay, so I'm going to now go to, good. All right. Really good, really good. So let me go to y equals on your calculators and type that in. What was the quadratic function that I'm going to type in here to y equals? Wait, did it say negative 2.5? Or what did it say? Negative 0.25 x squared minus, do I need to write 1x or can I just write x? Can I just write it like that? Isn't the 1 just understood? Now what about that 3 at the end? Is that plus 3 or minus 3? Take a look up at our example. It says quadratic function has a maximum vertex at negative 2, 4 and a y-intercept of 3. It is not a coincidence that that c value turned out to be 3. In the standard form of a quadratic function, if it's written out correctly, the c value is the y-intercept. And that's really cool. It's like in y equals mx plus b, if it's written correctly, b is the y-intercept. So 3 is going to be the y-intercept. Okay, let me show you guys something cool now. We want to find out the zeros. We want to find out the roots. Okay? And what that means is, where does this curve run right up into and cross the x-axis? So everybody hit graph. Not second graph, just graph. Let's see this thing. So what we're looking for, we're looking for that point, and we're looking for that point right there. Now they look pretty clear to me. But see, when I trace it out like this, look down here. My x values, they never get on a whole number. Go over here. So you kind of mouse back and forth and say, well, I think this is, what do you think this one is? What does it look like it is on the x-axis? Tell me. No, does that say -5 up there? It's right here. Okay, somebody said -6, right? Looks like -6, and go over here to the right one. What does it look like? 2. Alright, but here's the problem. We don't know for sure, and we're scientists here. We're not going to guess. So, let me show you this cool trick. Hit second, and then hit trace. Now we were told find all real roots. Okay, that's another way of saying find the zeros. So I need to go down to 2 and hit enter. Now it's going to place your cursor on the y-intercept, and it's asking you, look over here at this question. Left bound. You need to take your cursor and cursor all the way over. You can press and hold. Oops, too far. Until it's just a little bit to the left of where that line crosses the y-axis on the left side. Then hit enter. And it's going to draw in a little vertical line. Now it says right bound. Okay. What it means is I need you to put another boundary line around the y-intercept that you want me to study. Okay, so we're going to go a little bit to the right of where that first y-intercept is. I keep saying y-intercept. The x-intercept that you want me to study. Okay, so put your cursor a little bit to the right of that first x-intercept. Then hit enter again. Now you should have 2 vertical lines. Is anyone not here? Anyone confused or lost? We all produced this on your calculators. Now it says guess. Just hit enter. And look what it gives you. Zero is -6. Well, that was only the first one. So now we have to do that whole process again. Second, trace, 0. Now I'm going to, it says left bound. So I'll cursor over. This time I'm going to move all the way over here. I want to study this other x-intercept. Okay, right bound. Guess. Now that 0 gives me 2. Alright? So now we need to study how do I graph the function now? Well, if we were back up on our graph paper on the board, we can bubble in now these coordinates, -6 and 2. what we can do is connect the dots in a kind of curved way. You know, you want it to be smooth curves. But I've run into a problem. I have no idea what to do. Like, as this thing widens out, what's the next, where do I, you know, where does this go? Do I make it go like that or like that? You know, what do I do? So I'm going to show you now how to find functional values. So we said that our f of x equals negative 0.25 x squared minus x plus 3. So if I wanted to know where to plot my next point, I need to plug in x values and make it give me the y value. So what I need to do is take like f of negative 7, okay, and then equals negative 0.25, open parentheses, negative 7, close parentheses, squared, minus, open parentheses, negative 7, close parentheses, plus 3. Back in my day, I would have to just work this out. But there's a way to do that on the calculator. You might be tempted to say, just go to the tables, right? You could say, well, I know what to do. Go to second graph and just scroll down until I see x equals negative 7. And I know to graph y at negative 2.25. Okay, if I wanted to take f of 3, which would be the next increment on the right side of the graph, I could go back to x equals 3. And look at that. Negative 2.25. Okay? So that whole thing we talked about symmetry before. 1 to the left of the left 0, go back to the graph, whenever I'm here, okay, whatever that point is on the graph, it's going to be identical y value to the opposite side of the graph because they're symmetric. Okay? But here's the cool trick. So instead of going to second graph and looking at your tables, hit second window and change independent from auto to ask. Okay. Now hit second graph. Everybody getting a blank screen? Okay, you can put in any value you want. So this time we'll put in negative 7 for x, and it just gives me that y value. I don't have to scroll. And that can be fast. So like, if I wanted to know what the y-intercept of this was just to prove it, put in 0 for x. Should give me 3. Yep, it does. Put in negative 2 to check the vertex. Should give me 4. It does. Right? What's the axis of symmetry? Negative 2? Negative 2. It's just negative 2. X equals negative 2. It's a dotted vertical line passing right through the center. The key skill that we wanted to learn here was second trace. 0. Does everyone feel comfortable with that? Does everyone feel comfortable with stat edit, stat calc, quad reg? Now, are y'all going to, oops, I went to cubic reg. Are y'all going to remember this? Remember, you needed this, you needed this. You only had these 2 points. Okay? We're back to square one here. This is what we started with. Here's what you need. You need to know whether the thing is pointing down or pointing up. And you also need to know where the axis of symmetry is. It's always going to be at the vertex of the quadratic. So here's this is going to be the thing through which you need to dot a vertical line. Then you need to play a little game where you said, well, from this dot here I go down 1 over 2 to get to the y-intercept. So if I want to plot my other point, I can go down 1 and then go to the left 2. I need to reflect that exact thought process so I can create that third point. Oops. Right here. Now, then you create your XY table. Just plot, take the points, put them in here, then stick those into stat edit, stat calc, quad reg. And it's going to give you A, B, and C. C should always be the y-intercept. And this is standard form for the quadratic equation. Right there, y equals ax squared plus bx plus c. Graph it. Hit second trace, 0. Scroll over until you're a little bit to the left of the first x-intercept you want to know. Hit enter. Scroll past it to the right, hit enter. Then hit enter again. It'll guess that first 0. -6. Hit second trace again, down to 0. Scroll all the way back over to the right side now. But halt short. Don't pass that x-intercept again. Put the left boundary. Pass it again. Put the right boundary. 0. Or hit enter again. It'll give you the 0. And just as a final point, you could hit second trace if you didn't know what the vertex was. Okay, we know there's a maximum to this graph. It's not a minimum, it's a maximum. You're going to play the same game here. It says left bound. This time, we're going to go a little bit to the left of the top of the hoop. Right bound, go a little bit to the right of the top of the hoop. And it's going to actually guess the vertex point. See what it did? It said -0.199999. You have to infer that that's probably not, you need to round up, -2, (4). Okay, so even if you didn't know what the vertex was, you could find it. Second window, independent auto to ask. Okay. Then second graph lets you put in values. Put in 100, it'll give you the y value. Okay. Put in 1,000,000, it'll give you the y value. What is the range of this function? That's the last point I want to cover today. What is the range of this function? What's the range of this function? What is the biggest number this function can be? 4. Okay, so this thing looks something like this. So the biggest number this thing can be is 4. That's the top boundary. What's the bottom boundary? Negative infinity. So how do I write that in the terms of inequalities. So we know that we're going from negative infinity to 4. How do I write that in inequality notation? Negative infinity less than or equal to y, because we're doing range, less than or equal to 4. There's your range value. How about the domain? When you see this little cap, the little arrow cap, and you notice that starting from that vertex, the lines are diverging, they're going to continue to diverge forever and ever. So the domain of the quadratic is negative infinity, less than or equal to x, less than or equal to positive infinity, otherwise known as all real numbers. Okay, so what did we learn today? We learned what asymptotes were, how to identify them on a graph, and we did just a whole mess of stuff here with the quadratic function. We took just 2 points. We took the maximum vertex and the y-intercept, and we used the property of symmetry to find that other point. We created a table. We graphed it, we plotted it, we found the roots using second trace. That's those y-intercept points. We identified and graphed the axis of symmetry. We stated the domain and range of the function. You know, we did a lot. What's the standard form equation of a quadratic function? Peyton, tell me what it is. Okay, and Mackenzie, what does the C stand for in the y-intercept? Very good. Okay, I'm confident now that when you look at these STAAR test benchmark exams and you encounter these quadratic and asymptote questions, you will be able to do everything they're asking you to do. All right? Now this was recorded, and I'll stop the recording now, but please go on YouTube and watch this again if you need a refresher on the